All right, so for this game, we have a couple of things going on, but essentially the way that we'll set it up is with a two-tiered kind of sequencing setup. Essentially what we care about is we have time slots, so we have a sequential component for 1, 2, and 3 o'clock, but we also have to worry about the rooms in which the speeches are given. And what's going to happen is that for each of these time slots, there's going to be options to give speeches in the gold room and the rose room, specifically one in each. And in fact, the way this is going to work is that 1 and 2 o'clock are each going to have 2 speeches, one in each room. And then 3 o'clock is only going to have 1 speech in one or the other room. We don't know which one, so that's still up in the air. From there, we have the speakers themselves. We've got L, M, X, Y, Z. And I suppose let's take a look at the rules. So first rule says M has to go before L and in the same room. So there's a couple of things going on there, but I guess what I will do here is just symbolize M before L, and I'll use these horizontal lines just to kind of indicate that they'll be in the same horizontal parallel. They'll have to be in the same room, effectively. Next, neither X nor Y can be before Z. Now you'll notice that the wording here is kind of curious. It's not actually saying that X and Y are after Z, just that they cannot be earlier than Z. And anytime LSAT uses, wording that's a little bit, well, curious, you always want to be thinking about what they're trying to do. What's the angle here? And the angle here is that X and Y could potentially be at the same time as Z. So you could have something like X here and Z here, and that would entirely be consistent with the game. It's just that X and Y cannot go before Z. So I guess we can do something like X before Z and Y before Z. Effectively, neither of these can happen. Lastly, if L's speech is in the gold room, then X and Z must both be in the rose room. Now, we could do this as a conditional statement. Actually, so these kind of rules should kind of stick out a little bit, because this is similar to what you would see with an in and out setup, because in this game we only have 2 rooms, gold and rose, right? And this is basically one of those rules that says that if somebody goes into one side, then it'll push somebody else to the other side. And these kinds of rules should be familiar, because the common sense understanding of those rules is that at least one of those will have to go to that other side, the other side you're getting pushed into. So when you say that if L's in gold, then the other guys are going to have to get pushed into rose, in other words, what that's really saying is that either you're going to have L in rose, or alternatively, you're going to have X and Z both in rose. Because I guess another way of looking at it is to say this. If L is in gold as per this, then obviously X and Z will go into rose, so this will happen. But alternatively, if L wasn't in gold, then L would be in rose. So one of those two will have to happen. You'll have to either have L in rose, or you'll have to have both X and Z in rose. And actually, we can take one step further, because we know that M is before L, right? So if L is in rose, then what's going to happen is you'll have to have M in rose before L in rose. So at the very least, either these two are going to be in rose, or these two are going to be in rose, or some combination. For the record, it's not that only one of those will happen. So for example, you could actually have both of these guys in rose and also pick up one of X or Z. Obviously, we can't pick up both of X and Z because we only have 3 spaces under each room. But yeah, we could have something like M, L, and Z, or also X, either or, all go into the rose room. Now, from there, in terms of, I guess, exhaustion, I'm not sure there's much we can do here, because there seems to be quite a bit of flexibility. Z obviously can't go after X and Y, but you could have some combination of Z with one of them, or X and Y can go after. So, yeah, and the M before L, that also seems like it could be this scenario where you have them both in the rose room, but anyways, yeah, let's take a look at the questions. Question number 8 is our standard exclusion question. As usual, we go by the rules. So first rule, M before L and they're in the same room. Let's take a look. A looks good, B looks good, C is not. We have L before, oh no, C looks good, M before L. D, however, has L before M, which is not cool. And E has them in different rooms, so we can get rid of that. Next, we were told that X and Y, they cannot go before Z. So let's see A, B, and C. Answer choice A has Z in 1, so that's all good. Answer choice B has, oh, here we go, X before Z, so that's not going to fly, so we can get rid of answer choice B. And C has Z in 1, so there's no way to violate that rule. Last rule. Essentially, either we have to have L in the rows room, or we'll have to have X and Z both in the rows room. So answer choice A has X and Z in rows, so we're good. Answer choice C, you'll notice that we have neither. L is not in rows, and it's not both X and Z who are in rows. So answer choice C wouldn't work. The best answer to question number 8 becomes answer choice A. And as usual, let's just plug that into the board. A says M and L in gold, and then we have Z, X, Y in rows. Next, so the first local question we have here is number 10. Let's take a look. If X is at 3 o'clock, so first of all, I mean, if X is at 3 o'clock, I mean, we don't know which one, but he's going to be the only one at 3 o'clock because there's only one 3 o'clock time slot. So that means that in terms of everybody else, I guess one of these two is going to have to be M and L, literally in that sequence. And then the other one will have to be ZY, except it's not going to be Y before Z, so it's going to be ZY in that sequence. And I think both could still be okay. So yeah, we could do either ML or you could do ZY. And I suppose, okay, here, so if M and L are both in gold, then we're going to have X and Z both in rows. Z is obviously in rows anyway, but X will have to go down to the bottom. But if M and L are in the rows room, so if we trigger this side, then X can do whatever. X would still be able to go into either one. So to the question, which of the following cannot be true? Answer choice A. L is in the same room as Y, and no, they're definitely in different rooms. Answer choice B. M is in the same room as X. And wait, hang on, answer choice A, we just said L is in the same room as Y. That cannot be true. That actually makes it the correct answer. So A is viable. Just in case though, let's take a look at the rest of these. M is in the same room as X, and maybe because we said if M and L, if they both go into the rows room, X could now do whatever. So you could have had X in the rows room as well. That could have happened. Answer choice C, X is in the same room as Y. And yeah, that could easily happen. If you put M and L on top, then you could have ZYX in the rows room. That would have been fine. Answer choice D, X is in the same room as Z. That's the same thing, so D is out. E, Y is in the same room as Z, and they're definitely in the same room, so that could happen. So the only one that cannot be true is answer choice A for question number 10. Next, number 11 is global. Let's take a look at number 12. It's the next local question. So we have, if Y is at 1 o'clock. So if we happen to have the Y at 1 o'clock, well, I suppose Y can't go before Z. So it's going to be Y and Z at 1 o'clock. And I don't think we know which room. So, yeah, let's just do Y/Z are going to take over the 1 o'clocks. So from there, what do we have? We're going to have M and L with kind of the L stretching into 3 o'clock. So we know that we're going to have that. And then on the bottom, we're going to have, who's left? We have, just X, really. And not necessarily in the bottom, they could go in either direction. So if we have M and L in the gold room, then X will definitely be down here. But we could also have M and L in the rose room, and then that'll take care of this. And then X could go up top. I suppose the one other thing that we would know is that if we do have ML on the top, then the Z would have to go into the rose room as per this. So yeah, let's just we can say either we're going to have ML or we're going to have just X somewhere among those. So the question itself now asks, which of the following could be true? L is at 1 o'clock. And no, because L is definitely not at 1 o'clock. L is at 2 o'clock. And again, no, L is going to end up at 3 o'clock for sure. Answer choice C, M is at 2 o'clock. And yeah, you could have M at 2 o'clock in the gold or the rose room, really either or, but this could happen for sure. Just in case, let's take a look at the rest. X is at 3 o'clock. No, because we said there's only one 3 o'clock, and that's definitely going to have to be L right now. Answer choice E, X is at 1 o'clock, and no, the 1 o'clocks are taken up. So the best answer to question number 12 is C. Next, back to the globals. Question number 9. Which of the following pairs of speeches cannot be given at the same time? Okay, let's take a look. Answer choice A. Could we have L and Y both be given at the same time? Now this we've actually seen, because in this scenario over here, we don't know whether the ML was going to go gold or rose, but whatever would have happened, L would have been at 2 and Y would have been at 2, so they would have been given at the same time. So these guys definitely could have been. Answer choice B, could we have L at Z and Z given at the same time? Now, this we haven't seen yet, and I suppose you might kind of get a bit of a conflict between the L and the Z, because in order for L and Z to be given at the same time, first of all, they certainly cannot be given both at 3 o'clock because there's only one 3 o'clock slot. So for them to be given at the same time, it would have to be 2 o'clock. But if we did M and L, and then let's say Z down here, oh yeah, that's going to break, because then only one of X or Y will be able to go after. So the other one will have to go at 1 o'clock, but you can't have X or Y before the Z. So answer choice B is looking pretty good. Just in case, let's take a look at the rest. Can we do M and X at the same time? And yes, in this scenario that would have happened. M and X definitely both would have been at 2 o'clock. Answer choice D, can we have X and Y at the same time? And this we haven't seen as of yet. And I suppose, to be fair, they certainly can't both be at 1 o'clock, because then you would end up with Z afterwards. But could we have X and Y both at 2 o'clock? And maybe that seems okay, right? Because you could put Z at 1 o'clock so that you're avoiding these rules. And then M before L would just go into the remaining 1 and 3, which seems entirely fine. Answer choice E, could you have Y and Z at the same time? And yeah, that we've seen literally right there, so that easily could have happened. So the best answer to question number 9 is B. Next, number 11. Which of the following is a complete and accurate list of speeches, or could be a complete list of speeches given in the gold room in order? So what could be the complete setup of the gold room? So answer choice A, could we do LM? And definitely not, because these guys are out of order, so A is out. Could we do MY? And no, because M has to be in the same room as L. M and Y will never be the complete gold room. Answer choice C, can we do MYL? And maybe, we haven't seen that yet, but I think we just discussed that one, because if we did M, Y, and L in the gold room, then you would have X and Z both in rows. You could have Z in 1 and X in 2, and that would have been entirely okay. So answer choice C is looking pretty good. Just in case though, can we do Y, Z, X? And no, because that would place the Y before the Z. That's not cool. Answer choice E, can we do Z, M, L in gold? And maybe, actually, if you did Z, M, and L, oh no, because either the L has to be in rows or both X and Z have to be in rows. So there's no way to put Z and both of M and L in rows. So that's not going to fly. So best answer to question number 11 is C. Lastly, question number 13. Which of the following if we replace the rule that X and Y cannot go before Z? So it's this guy over here. So we're trying to replace this set of rules about X and Y with another rule that'll have the same effect. Now remember, for these kind of questions, you've got 2 parameters. We're looking for something that always had to be true, and something that, if it was true, it would ensure that this essentially will be maintained, that you'll have to have X and Y, well, not before Z. So let's take a look. Answer choice A. L must be at 3 o'clock. Now this is an easy cross-off because we know that L didn't have to go at 3. We've seen cases where L has been at 2 o'clock, so A is out. B, M cannot be earlier than Z. Now, is that true that M could not be earlier than Z? I suppose we haven't seen it earlier than Z, so maybe it's always been somewhere later. But I guess the real question is, would that get the job done? If we say that M cannot be earlier than Z, would that really ensure that X and Y will be? But no, because couldn't you then do something like M could go at 1 o'clock and then Z could go at 2 o'clock? Or let's go with the rows room, because to avoid this issue. If we do m over here and then z over there and then l over here, so you'd have m, z, l, then wouldn't that easily allow for one of y or x to go before? And yeah, that doesn't seem like it would be enough to ensure this will be maintained. So answer choice B is out. C, either x or y must be after z. Now, that's true. Well, yeah, that's kind of obviously true that one of x or y had to go after, because we know that they could not go before, and only one of them could be at the same time. So the other one, at least one of x or y, would have to be after z. But the real question now is, would that really be enough? If we implemented this as a rule that one of x or y has to go after, doesn't that still allow for the other one to go before? And it seems like it easily would. So for example, you could run something like y, z, and x in 1, 2, and 3, and one of them would be after, but then the other one would have been before, and that would have broken the rule. So even though answer choice C had to be true, it's not enough. It doesn't guarantee, it doesn't stop these guys from going before the z, at least not both of them. Answer choice D, either x or y must be at 2 o'clock. Now, does that have to be true that one of x or y had to be at 2 o'clock? And I think it might have been, because I guess could they both be at, well, no, they couldn't both be at 1. We said that much. But wait, couldn't we do something like have them at 1 and 3? So if we put, let's say, x and or z and y over here, and then, no, I guess that also couldn't work because that would force m and l to be at 2. So it seems like this had to be true. But the real question then becomes, does that really ensure that they're not going to go before z? And, well, no, I suppose it doesn't, does it? Because wouldn't that allow for you to do something like, let's say x could go at 2 o'clock, z could go at 2 o'clock, or let's go the other way, y could go at 2, z could go at 2, and then x could go before at 1, and then m and l would fit into the gold room rather easily. So this would not be enough. Even if we say that one of x or y would be at 2 o'clock, that would allow for one of them to be with z at 2 o'clock, and the other one could still end up before z, which is what we're trying to avoid. So answer choice D, still not good enough. Answer choice E, z must be at 1 o'clock. Now that'll certainly get the job done, right? Because if z is at 1 o'clock, then it's impossible for x and y to go before. But then the real question really is, wait, did that have to be true, that z had to go at 1 o'clock? I mean, couldn't we potentially have had z at 2 o'clock? Because if we put, hypothetically, if we put a z into 2 o'clock, oh no, that's going to break, isn't it? So if we put a z into 2 o'clock, you'll notice that since neither of these guys could go before, then what would end up happening is that one of them would have been here with z, and then the other one would have ended up somewhere at 3 o'clock. Now, 3 o'clock would be locked, though, because you can only have one person at 3. So that would leave you with m and l having to go both at 1 o'clock, except they can't. They have to go in the same room. So this technically had to be true this whole time. Z has always had to be at 1 o'clock. And if we implemented this as a rule, then it would certainly ensure that x and y are not going to go before z. So this fits both parameters. The best answer to question number 13 is E.